Hi. When I heard about the release of the Agent Lightning library, I thought, wow, I really need to look into this. So I haven't managed to fully deep dive into all the capabilities. I looked mainly at the automatic prompt optimization, and this is what I'm going to talk about today. And I know I'm scratching the surface, but this has significant potential. And I don't understand why Microsoft are not banging about this much more. It's really hard to find videos and posts about this. And I know, yes, it's being developed, and the videos that I found on the internet are kind of referring to an older version, and it's evolving, and the potential behind this is unbelievable. So, in this video, I'm going to talk about technically what I've learned about getting the automatic prompt optimization working. I'll do also a few videos about what are the use cases that I think are relevant and how to set up the um, wider technological or enterprise um, solution architecture for this. It's already at the back of my mind. I did half a year ago, a little bit more. I did a video about the fine tuning capabilities that Microsoft released into Foundry. I thought it was unbelievably amazing. I did try to get it to do something based on some paper that I read, if you remember, uh, trying to get to, the fine tuning to ensure that not only the behavior of the response is custom to the particular type of response, voice, and knowledge, but also that when it um, assesses the accuracy of what it's saying and recommending or classifying, that probability of how accurate I am is also built into the fine tuning. So you teach it how to be more precise on the estimate of the probability. Didn't get that to work, and I'm hoping with this new Agent Lightning, I might get closer to that. Not in this video. The reason I'm excited about this because it's taking us closer to that holy grail of being effective. At the moment, the LLMs themselves, the base models, the RAG, it's kind of automation, clever automation, flexible automation, unbelievable, powerful automation, but it's not there yet with regards to the recommendation engines, the classification, the optimization recommendations, and scenario modeling, which I think we are now with this technology much closer by far to be able to do that. So you've got an agent, and what defines an agent we all know is the system prompt that tells it what it is all about, and the base model that is behind it, and the tools that we give it to use. That's kind of already um, clear to most people in this field. Uh, the user gives a prompt saying, please do this, and we get a response. And this is where this new tool comes in. Having that agent, no matter what platform you use to create that agent, it's disconnected, so it works with all the other platforms possible, which is cool. That's a really, really important point. They have this system that wraps around the agent or the agentic system that we are providing it. First of all, as in any good reinforcement learning, there's an evaluation step that looks at the response and has a way to say what you told me is correct or incorrect, or the impact of the recommendation that you've given me has generated this outcome. Now I can calculate a reward based on the accuracy or the outcome of the action, and I'll feed it back to you. But to feed it back, you don't feed it back to the agent. You remember it, you store it. There's a whole system around the trainer, how to automate it and how to make the decisions, to enable actually an algorithm to look at the rewards and suggest more interaction with the agent. Now, the word I originally thought that the prompt optimization also will be reinforcement learning. It's not a reinforcement learning, it's a good old classical optimization with a tweak around the prompt engineering, which is cool. It's really, really cool. It's latest technology. But it's an optimization algorithm. It's using really wise operations research and machine learning. So what is the feedback back to the agent? It could be, so it says, okay, here's a task. So I, as an algorithm, based on the historical rewards that I've seen beforehand, so this is the history, I know what I've tried in the past, this is what works well, this is what doesn't work well. I would like you to try out a few other things for me to see uh, if I can make you work better. Now, what does it mean, work better? I can try and change the system prompt, or I can do fine tuning of the instruction, or give you instructions to fine tune the base model that underpins the agent. Here, I'm going to focus on the optimization of the system prompt. I'm more excited, really excited about the fine tuning element that I will get to later on, I hope. So once I've run it, I tried the booking, the room booking demo that they have provided, and I'll show you the code in a second. But just to see at the end of running it, you can see that we started with a score of 72, and it improved it to almost 90. Significant improvement, and actually they've just done 2 runs. You can see here the history of each round had five different versions of the prompt. And you can see the original prompt is a very simple, basic prompt. Then it tried a more elaborate prompt. Prompt 4 here with a score of 0.9 is the one that works best. You can see that if you go for a too long prompt, you also can shoot yourself in the foot. Before I talk about this, let me just show you the code for a quick second. I had to change it a little bit. Interestingly, to run this, the code is deceptively simple. See, you have here a very small loop. I am going to connect to the Azure OpenAI. This is the parameters that I'm setting for this, and I'll talk about it in a second. Here's the trainer, and that's it. Now, the secret is that it's simple because the definition of the agent and all what's behind the job is brought in from here. So this room selector.py is a much more elaborate, complicated code with a nice definition of classes, and the original prompt and how the prompt looks like and so forth, which takes a little bit of time to dig in and understand. As you saw in the code, it's important to define the hyperparameters of the algorithm. This should feel terribly familiar to anybody who's a data scientist. You define how many runs to run, how big the batch is, and this seems to be the important one, which is how many times you're going to iterate. Interestingly, I didn't see, although in the papers behind these algorithms there are stopping rules, I don't see a stopping rule that says, oh, when the accuracy stops to improve, stop there, like I'm used to from genetic algorithms, for instance. The algorithm itself seems to be one of these where you generate new cases, new prompts to try out, and you use an LLM, and this is important. You use an LLM to assess the quality of the recommendation, of the response, of the action, or assess what would be the outcome of this action. In the generation, it's not a simple thing to say, "Oh, I'll generate a new prompt." There's a lot of sophistication and cleverness that goes into what will be an iteration of this prompt to get perhaps a better one. So it's learning from the past, runs, and there's a lot of cleverness with regards to looking at the journey. Just a few notes about how I got this repo to run. It wasn't that hard, but of course, I needed an Ubuntu machine. At the moment, this code, according to the documentation, I didn't try, but according to the documentation, is not tested on a Windows machine. I don't mind that. As I said, I used Azure Foundry as my service rather than OpenAI itself. And originally I said, oh, if I'm installing a new Ubuntu, why shouldn't I just go for the latest Python, which is 3.15? I'm not recommending it yet. Not only crew.ai didn't work, there's other things that didn't work nicely. So I just went to 3.13 again. The developers decided to track the progression of the algorithm using Pommel, which records the traces of the algorithm in a standard way that you can access it from other devices, other applications, and so forth. I wrote my own code to analyze the Pommel and give you that summary that you saw beforehand. Let me show you quickly if I go to the VS Code again. So when you run the code, you get APO log, which gives you information here. And the Pommel trace, you get for each one loads of information that you can analyze. So my assisted coder wrote a code, APO analysis report, which runs on the APO log and the trace and gives me the results that I need, that I showed you in the screenshots. Thank you very much for listening. I will continue diving into this amazing and exciting package. I believe there's a lot of mileage here, and I'm really curious to see what the developers will put in for the next versions, because this is at the moment only in version 0.2. Thank you.